How you doing, folks? Mr. D here, and welcome to section 3.4. We're going to be looking at implicit differentiation, which sounds pretty complicated. What does implicit mean? Let's take a look. Let's look at what an explicit, the opposite of implicit, is. Well, an explicit equation is something like y equals, x plus 16. And it's explicit because it is obvious what the dependent variable is, the y. And that's when we get introduced to functions. It's very clear. I've got the y all by itself, and then I have all the other stuff on the other side. Okay? It's clearly, that's what they mean by explicit. It's obviously and directly explained to you which thing is independent and which is dependent. Okay? When we differentiate those, we just take the derivative of the expression, usually with the x in it, the stuff on the right. An implicit equation is something like, let's say we have an equation of a circle, like x squared plus y squared equal to 16. In this instance, the x and the y are mixed together. Okay, it's not as obvious which one is the independent and the dependent. Okay, so gets a little bit trickier to be able to solve for the derivative. And again, that would look something like a circle. So the derivative can be more than one thing at a particular x value. Okay, so it just depends on which y value you want to use with that x value. So we're going to find the derivative explicitly of this first equation. So if we want to do it explicitly, we want to end up with y equals, and do it just like I talked about traditionally. So what I would do is try to solve for y. So let's see, I want to get rid of the 3x, so the opposite of the 3x, I'll subtract it. And so I have y squared equal to 5x cubed minus 3x. I didn't write the x there. And then I get rid of the square by square rooting, so I have y equal to plus or minus the square root of 5x cubed minus 3x. Okay? So usually when we take the derivative, we want to change square roots to exponents. So if I rewrote that as y equals plus or minus parentheses 5x cubed minus 3x to the 1/2 and tried to take the derivative, I'm going to do the chain rule for that. Okay, so the outside function for this is the 1/2. So I would bring the 1/2 down. So I'd have 1/2. And then I would drop the power of the 1/2 by 1. It would become negative 1/2, which would mean it would be a square root in the denominator. So I'm going to have the square root in the denominator with the 2 of the 5x cubed minus 3x. And then I take the derivative of the inside function, which is going to be 15x squared minus 3. And that'll multiply into the numerator. So I end up with 15x squared minus 3 over 2 root 5x cubed minus 3x. Okay? Sometimes that's the easiest way to do it. Okay? We're going to find sometimes it's really hard to solve for y, or even once you solve for y, it's hard to find the derivative. So that's where we talk about right here. I just say when you can't isolate in terms of x, or taking the derivative is crazy, then we do what's called implicit differentiation. Okay, so let's look at what those steps look like on the next page. And we're actually going to do the exact same example. And then I want to check back and compare to see if we got the same answer. Okay, so when you're trying to find a derivative, you're trying to basically find at y prime or f prime or dy dx, okay? So each time we differentiate and you have a y, we're going to add a dy dx into this equation. So I'm going to recopy this equation down here. So I've got y squared plus 3x equal to 5x cubed. And so when I take the derivative of the y squared, I get 2y, but because it's a y there, I write dy dx. And then the derivative of the plus 3x is plus 3 equal to the derivative of 5x cubed is 15x squared. Okay, so I did step 1. So then what we're going to do, step 2, is we're going to get all the dy dx terms on the left side and get rid of everything else. So I've got the 2y dy dx. I'm going to keep that on the left, but I want to get rid of the plus 3. So I'm going to minus the 3 from both sides. And so I have 2y dy dx equal to 15x squared minus 3. Okay. And then what we're going to do is factor out step 3, the dy dx. I've already got the dy dx separate from the 2y. So I'm pretty much did that one step. It's already factored and separated. I've only have the one term. We'll see some examples in a minute where you have more than one dy dx. But lastly, we're going to solve for dy dx. So right now, dy dx is being multiplied by 2y. So I'm going to do the opposite, which is I'm going to divide by the 2y. And so I've done it. I've got dy dx equal to 15x squared minus 3 over 2y. Okay, now let's look back at what we had because it looks a little bit different. Okay, this one has the 15x squared minus 3 divided by 2. Instead of a y, it has this. But if you look, sometimes your forms may look different. But if you look, what's y equal to? Y is actually equal to the square root of 5x cubed minus 3x. So all I did in the implicit actually looks simpler. It replaced the square root of the 15x minus 3x with a y because that's what y is equal to. So they are actually the same thing. It might be a little bit different form when you do it that way. So let's look at a couple more examples. So again, step 1, we're going to differentiate. So I've got the y cubed, so that's going to give me 3y squared. And that's a y, so I add a dy dx minus 2 equal to 4x cubed plus 2 dy dx. So this time, notice, I have 2 dy dx terms. Okay, so I'm going to put those on the left, and then I'm going to put the negative 2, I'm going to move that over to the right. So that's going to leave me with 3y squared dy dx, and then I subtracted the 2 dy dx, so I got minus 2 dy dx equal to, I have 4x cubed, and again, I'm bringing the minus 2 over, so it's going to be plus 2. Then notice, now I've got 2 dy dx terms. So what I could do is I can factor that out. Sometimes I call that doing the reverse of distributive property. I'm going to factor out the dy dx outside of the parentheses, and I'm left with 3y squared minus 2 equal to 4x cubed plus 2. And then lastly, solve for dy dx. Well, it's being multiplied by this expression, so I can just divide by that expression. So dy dx is equal to the 4x cubed plus 2 equal to the 3y squared minus 2. And there you have it. There's your derivative function. Okay, one more. We've got 3x squared here, so that will be 6x. Ooh, what's going on here? So now I've got two expressions. I'm going to make 4x be my first expression, and it's multiplying by y squared. So I have to do the product rule for that, okay? So I'm going to have f prime s plus f s prime. I use, and if you've watched my earlier videos, I use f and s for just first and second factor. So the derivative of the first, the derivative of the 4x is just 4 times the second, which is y squared. Now notice I don't put a dy dx in there because I didn't take the derivative of y squared. I just wrote that down. And then I've got f s prime. So the f, the first thing is the 4x. And now I'm taking the derivative. I got to give myself some more parentheses there, more space. I'm taking the derivative of y squared, which is 2y. And I have to write a dy dx right there. And then I've got, I should shrink this down and give myself enough room. Okay. So then I've got the derivative of minus 5x cubed, which is minus 15x squared, dy dx. And the derivative of 10 is 0, so equal to 0. Okay? So now I have, let's clean this up a little bit. So I've got the 6x still, plus the 4y squared, plus, and then let's see what we got here. We've got 4y and 2y. 6x, so let me just check over my work. So I've got 6x plus 4y squared. That gives me, I'm sorry, that's a 4x, sorry. So that's what I was looking at. So I've got 8xy dy dx minus 15x squared, 15y squared dy dx. So I have two dy dx terms. I've got this term, and I've got this term, and it's equal to 0. So I'm going to get rid of the 6x and the 4y squared by subtracting them. So I still got the 8xy dy dx minus 15y squared dy dx equal to, and again, I'm reiterating, I'm subtracting the 6x, so it's minus 6x, and I'm subtracting the 4y squared. So now I have two dy dx terms right here, so I'm going to factor out the dy dx, factored out, and I'm left with 8xy minus 15y squared, parentheses, equal to negative 6x minus 4y squared. And then lastly, I'm going to divide by the term the dy dx is being multiplied by. So I end up with dy dx equal to the negative 6x minus 4y squared divided by 8xy minus 15y squared. Now I want to point out, you may have noticed I had to stop there for a second. It's real easy when you're doing this, if you're doing it fast, to mix up your x and your y's. Up here I had a 4x that I wasn't real careful about, and I thought it might have been a 4y. So that's why I had to hesitate and be sure, because I was writing quickly. So again, that's just something to watch out for. It's real easy to do, and you totally know how to do it. It's just you misread your problem. Okay, so now we're going to do a little application example. We're going to find an equation of a tangent. Okay, that's a line. So ultimately, when you have a line, you're going to need an xy point, and you're going to need the slope. Well, dy dx, we know, that equation will give me the slope. And I want to find the tangent line when x is equal to 1, so I already have half my point. I just need to know what the y is. So if I plug in the 1 into that equation, that'll give me what y is. Well, 1 squared is 1, so I get 1 plus y squared equal to 4. Subtract the 1, so I get y squared equal to 3, and then square root, and you get positive or negative 3. Positive or negative root 3. And the reason for that is this is a circle with radius 2, and so when x is equal to 1, I actually have a point up here at 1 positive root 3 and a point down here at 1 negative root 3. So this is actually going to be 2 answers to this. Okay, so let's do now, we need the, let's just say positive or negative root 3 for the point. Okay, and so now let's find the dy dx to find that slope. So I'm going to recopy this down. I've got the x squared plus y squared equal to 4. And I differentiate. So I've got 2x plus 2y dy dx equal to 0. So I'm going to get the dy dx term by itself. So I'm going to subtract the 2x. So I get 2y dy dx. That's equal to negative 2x. And then lastly, I'm going to divide by the 2y. So dy dx is equal to negative 2x divided by 2y. Okay, so that'll give me my slope. And I know I'm going to be plugging in 1 for the x. So let's write down, we're going to do 2 equations here. I've got the 1 positive root 3, and then I have 1 negative root 3. Okay, so when I plug in the 1 and I put in positive root 3, my slope is just negative 2 over 2 root 3, which is negative 1 over root 3 for the slope. Okay, and so that equation would be, I'm kind of running out of room here, sorry about this, but I've got y minus root 3 equal to my slope, and I'm not going to rationalize here, but that's fine for this exercise, negative 1 over root 3 for the slope, and then the parentheses x minus 1. So that's one tangent line. Okay, and then for the 1 negative root 3, the sign's just going to be the opposite. It's going to be positive 1 over root 3. So that line would be y plus root 3, because it's negative root 3, minus a minus, equal to 1 over root 3, parentheses x minus 1. Okay, so if I put in, did I get that right? If I plug in the positive root 3, that gives me negative 1, right? And if I put in the negative, negative over negative gives me positive. Correct. Okay, so lastly, we're going to look at finding a second derivative. So we're actually going to have to do this twice. Okay, so here's my equation. Okay, so the derivative of cosine is negative sine y. And so it's dy dx equal to 4x. And so to solve for dy dx, I divide by negative sine y. So I get dy dx equal to 4x divided by negative sine y. Okay, so I've got this bad boy right here. That's my first derivative. But now I'm going to differentiate that again. So now what I have is I have a quotient. Okay, so remember, the quotient rule is you get the top, t is the top, b is the bottom, numerator, denominator, just keep it simple like that. And so the derivative is t prime b minus t b prime over b squared, okay? So in this instance, my t is the 4x, my b is the negative sine y, my t prime would be just plain 4, and then my b prime would be negative cosine y. And again, I took the derivative of y, so it's dy dx. And then it's just a matter of plugging that stuff in. Now, notice I've got a dy dx. That's where I'm going to substitute in the original dy dx, so I don't have a dy dx left in my equation. So for my final product here, where I have the dy dx, I'm going to put the 4x over the negative sine y. And that's pretty much how you do it. So let's set this up. So I've got parentheses, parentheses, minus parentheses, parentheses, over parentheses squared. And so for my t prime b, I'm going to have 4 times negative sine y minus tb prime. So I'm going to have 4x times negative cosine y, negative cosine y, and then I'm going to times the 4x over negative sine y. And in the bottom, I've just got the b, which is negative sine y. And so let's try to clean this up. The 4 times the negative sine y, that's just going to be negative 4 sine y. And then I've got a lot of multiplying here. I've got a negative right here because it's minus. So I've got a negative cosine y, and then a negative. So I've got 3 negatives there, which will be negative. Okay. And so I've got the, let's see, I've got the 4x and the 4x. So I'm going to get 16x squared times the cosine y in the top, and in the bottom, I've got the sine y. And that's all over the negative sine y, which is squared. Well, when you square a negative, that'll become positive. So I get sine squared y. Now what's happening here is basically I'm dividing a sine squared into each one of these terms. So if I divide into this term, one of the signs will cancel with this. So I'll end up with negative 4 over sine y minus, and when I divide it into this one, I'm going to have 3 sine y's. So I end up with 16x squared cosine y over sine cubed y. So that's the second derivative, d squared y over dx squared, equal to that. And so let's just review what we did. So what we did with implicit differentiation is we differentiated and we add dy dx added to each y term. And then we collect the dy dx terms. And then we solve for dy dx. Okay. You could just add the second derivative we just do it twice. And substitute for any dy dx's the second time around. All right, so that's implicit differentiation. I hope you enjoyed this video. Please don't forget, this is Mr. D. Don't forget to like and subscribe this video, and have a great day. Thanks a lot. Bye.